Today, our topic is about proving theorems related to central angles and their corresponding arcs. Take note that this is for the second quarter and from Module 4, Version 5. I am Teacher Anthony G. Arisgado, your ever wonderful and joyful teacher in math. Let's go! The objectives for today's lesson. At the end of this session, the learner would be able to complete the missing data in the two-column proof to prove theorem related to congruent central angles and their corresponding arcs. And we have there solve problems related to the theorem on central angles and their corresponding arcs. Are you ready? If you are, let's go. We have to remember these three terms. The first is the definition. The definition is the formal statement that describes what the term is. And another one, postulate, is a statement that is accepted as true without any proof. And the last statement to familiarize, or the last term, is theorem. Theorem is a statement that has been proven to be true by accepted arguments such as definition, postulates, or other theorems. Okay, for our lesson proper, we have definition 1. The degree measure of the minor arc is equal to the degree measure of its central angle. I hope you will remember this definition 1. So let's see the figure representing or showing us that the definition 1 is what the definition 1 is talking about. Now we have here a circle O, and the circle O has points T and P, which form a central angle TOP. Say the measure of our central angle TOP is 82 degrees. Now the measure of our arc TP must also be 82 degrees because of the definition 1. Okay, so in other words, by definition 1, the measure of arc TP is 82 degrees because its central angle is 82 degrees. Definition number 2. Congruent circles are circles with congruent radii. Say we have a circle A and a circle U. Our circle A has a radius AT and our circle U has a radius UP. Now, by definition 2, circle A is congruent to circle U if and only if radius AT is congruent to radius UP. Get it? Let's go. Arc addition postulate. Arc addition postulate states that the measure of the arc formed by two or more adjacent non-overlapping arcs is the sum of the measures of the arcs. Example, we have a circle W having, a number of arcs and a number of central angles. Now, we have the measure of angle OP, arc OP, which is 95 degrees, and the measure of arc PE is 85 degrees, and the measure of arc ER is 30 degrees. Now, if we are going to solve for the measure of the major arc OPR, then we are going to just add by following the arc addition postulate. Say the measure of arc OPR is equal to the measure of arc OP plus the measure of arc PE plus the measure of arc ER, which is equal to 95 degrees plus 85 degrees plus 30 degrees. It is equal to 210 degrees. And if we are going to add to the 210 degrees the measure of our arc OR, the total is 360 degrees because the circle is being divided into arc OR, arc PE, arc ER, and arc RO or arc OR. Okay? I hope you get that explanation. Now, for Theorem 1, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Example, we have a circle U having points F, L, M, E, S, and they form arcs and central angles. Now we have arc LF intercepted by our angle LUF or angle FUL. Also another arc intercepted by angle SUE. Now we can say that the measure of arc LF is equal to the measure of arc ES if angle LUF is congruent to angle SUE. And if they are congruent, we can also say that arc LF is congruent to arc ES. Okay? And if we have another circle, say circle P, and circle P formed a central angle APT having an arc AT, we can say that arc AT is congruent to arc ES if angle SUE is congruent to angle APT. Just like this statement by Theorem 1, arc LF is congruent to arc ES and they are congruent to arc AT if and only if angle FUL is congruent to angle SUE and they are congruent to angle APT. Let's try this theorem by proving some statements. Example number 1. Given circle W is congruent to circle N. Another given, angle AWS is congruent to angle MNR. Prove that arc AS is congruent to arc MR. With this figure, we have circle W having a central angle AWS and circle N having a central angle MNR. Let's go. Now the proof. Okay, before writing the proof, we are going to put the given on top. So our way of proving whether arc AS is congruent to arc MR. Are you ready? What we are using is the two-column proof. For the left side, the statements, and for the right side, the reasons. Let's start now. Our statement number 1 is, of course, it's been written on top, and the reason for this is the given. For our statement number 2, in circle W, the measure of angle AWS is equal to the measure of arc AS. And in circle N, the measure of angle MNR is equal to the measure of arc MR. Do you know or can you still remember the terms we discussed? course, it's the definition 1. The degree measure of the central angle is equal to the degree measure of its intercepted arc. Okay, now from the given or the statement 1, we can say that the measure of angle AWS is equal to the measure of angle MNR. Reason? It's the definition of congruent angles. And with respect to our statement number 2, we can make use of that to create our statement number 4, which is the measure of arc AS is equal to the measure of arc MR, using statement number 2 for number 3. Meaning to say, we are substituting. Okay, so substitution property, substitute measure of angle AWS equals measure of arc AS. Okay, to statement 3, so we have measure of arc AS, and the measure of angle MNR equals the measure of arc MR. Substitute it to statement number 3 to have measure of arc MR equal to the measure of arc AS. Lastly, we can say that therefore the arc AS is congruent to arc MR. Why is that? Definition of congruent arcs. Statement number 4. If the two measures are equal, so say the measures of the arc AS and the measure of arc MR, if they are equal, then the two arcs are congruent. So, we have proven Theorem 1 correct, and we can make use of it to prove any other examples. Let's try to use it again in activity 1. So we have here activity 1 from the module. So complete the 2-column proof for each of the following. So we have here letter A, we have given angle QPR, which is a central angle, is congruent to another central angle SPW, given the figure, the circle there, the circle P. Now, prove arc QR congruent to arc SW. Okay, so the good thing is that all the statements are given already. So all you have to do is find the reason. So easy, right? Let's go answer the activity 1. So still we put the given on top, and then the proof is of course the 2-column proof, copying all the given statements. So what do you think is the reason why our first statement is angle QPR congruent to angle SPW? Of course, it's the given. Very good. Statement number 2. The measure of angle QPR is equal to the measure of angle SPW. Why? Using the first statement, it's because of the definition of congruent angles. Correct. Now, statement number 3 says the measure of angle QPR is equal to the measure of arc QR, and the measure of angle SPW is equal to the measure of arc SW. Reason? Yes, the definition 1, right? The degree measure of the central angle is equal to the degree measure of its intercepted arc. Now, statement number 4. Measure of arc QR is equal to the measure of arc SW. Why? Okay, substitute statement 3 to statement 2. Okay, therefore, we can say that arc QR is congruent to arc SW because of the definition of congruent arcs, or definition of congruence. So that's how easy it is to prove. If you find it difficult, don't worry. I'm not giving you any more proving, but the application of Theorem 1. Are you ready? So here it is. What's my degree? Using the figure of a circle E. Okay, so find the measure of the following if, okay, so CD and the line segment CD and the line segment BF are diameters of circle E. Okay, you can see it there in the figure. Number 1, find the measure of angle AEB. Okay, number 2, find the measure of arc AC. Number 3, find the measure of angle CEF. Number 4, find the measure of arc FD. And find the measure of arc ABD. Can you do that? Don't worry, I will help you. Let's go! So, find the measure of angle AEB using the figure. Take note that in the figure, line segment CD is, okay, a diameter, very good. And the measure of angle CED is 180 degrees. Now, we have the measure of angle AEB. Okay, by the way, if we are going to add angle CEA plus angle AEB plus angle DEB, it is equal to 180 degrees. Now, to solve for angle AEB, we'll have 180 degrees minus the 60 degrees there for angle CEA and 75 degrees from angle DEB. Okay, and the measure of angle AEB is equal to 45 degrees. I hope you are able to solve that one. Let's proceed to number 2. Find the measure of arc AC. To solve, well, you just apply the definition 1. If the central angle CEA is equal to 60 degrees, the measure of the intercepted arc AC is also 60 degrees. That's what I'm talking about. So I hope you get that one. Let's go to number 3. Find the measure of angle CEF. Okay, so the first thing that we're going to consider is the measure of angle AEB, which is 45 degrees when we solved earlier, right? For number 1. And also, line segment BF is a diameter. Therefore, we can say that the measure of angle CEF is just 180 degrees minus 60 degrees minus 45 degrees. The answer in number 1. So, simplifying, the measure of angle CEF is 75 degrees. Any question? None? Very good. Number 4. Find the measure of arc FD. So, arc FD there is, okay. So, we are going to consider the measure of angle BED. Why? Because they're connected. Arc BD and arc DF, okay, makes up the semicircle with line segment BF as a diameter. Okay? So, then we can solve as simply as, okay, 180 degrees minus 75 degrees. By the way, we can directly solve it because the measure of arc BD is 75 degrees also by definition 1. So if we're going to subtract 75 degrees from 180 degrees, it is equal to 105 degrees. And that is the measure of our arc FD. And the same measure for our angle FED. Okay? So that's how we solve or how to find the measure of arc FD. Okay? So that is how we solve for the measure of arc FD. Number 5. Find the measure of arc ABD. Okay, so I hope you can still remember the arc addition postulate. Okay, so To solve, we are going to find the measure of angle BEA, which is 45 degrees as we solved in number 1, and the measure of angle BED, which is given as 75 degrees. So, follow the arc addition postulate. We can have the measure of angle AED equals 45 degrees plus 75 degrees. That is equal to the measure of arc ABD. Okay, so the measure of arc ABD is equal to 120 degrees. As simple as that. If you have questions, please post it in the comment section. Okay? Thank you very much. Good job, everyone. I hope you learned something new today. Again, this is Teacher Anthony G. Arisgado, Grade 10 Mathematics Teacher of Bukidnon National High School. See you next time!